Rational expression is just another word for fraction, and now we are going to multiply rational expressions. Let's start with the first fraction, 2y squared minus 6y minus 8 over y squared minus y minus 2 times y squared minus 5y plus 6 over 2y squared minus 4y minus 6. The only way we can multiply these fractions is to multiply the numerators and denominators. We don't want to multiply them in this form because that would be too much work. So we're going to write them in factored form and divide out any common factors. Let's look at the first numerator. Remember when factoring to look for the GCF, or greatest common factor, among all of the terms. Between 2y squared, 6y, and 8, there is a GCF of 2. That leaves us with y squared minus 3y minus 4 over the denominator. Now let's factor the denominator, which does not have a GCF, since it is a trinomial with leading coefficient 1. We will write in y and y. Now we are looking for two numbers that have a product of -2 and also have a sum of -1. Let's try -2 and +1. The product is -2 and the sum -1. We will write in -2 and +1, and then we will write in the multiplication sign. Let's factor the numerator of the second fraction. Notice that the leading coefficient is 1, so we will write in y and y. Now we are looking for two numbers that have a product of 6 but a sum of -5. Let's try 3 and 2. We will make them both negative to get the product of +6 and the sum of -5. Now let's look at the denominator of the second fraction. Notice that we have a greatest common factor. We can factor out a 2, which leaves us with y squared minus 2y minus 3. But we need to make sure that we are in the completely factored form before we start dividing out common factors. Notice that we can still factor in the numerator of the first fraction and the denominator of the second fraction. We are going to factor the numerator of the first fraction. We will write in y and y because the leading coefficient is 1. Now we need to find two numbers with a product of -4 and a sum of -3. -4 and +1 add to -3, and they have a product of -4. Since the denominator is already in factored form, we'll just recopy it as y minus 2 and y plus 1. We will write the multiplication symbol and the numerator of the second fraction since it is also in factored form, y minus 3 and y minus 2. Now we have to factor the denominator of the second fraction. Again, the leading coefficient is 1, so we will write y and y. We are looking for two numbers with a product of -3 and the sum of -2. The product of -3 and +1 is -3, and the sum is -2. Now we can divide out the common factors. Let's start with y minus 2 in the denominator of the first fraction and y minus 2 in the numerator of the second fraction. Then, we have y plus 1 in the numerator of the first fraction and y plus 1 in the denominator of the first fraction. Next, y minus 3 in the numerator of the second fraction and y minus 3 in the denominator of the second fraction. We also have a 2 in the numerator of the first fraction and a 2 in the denominator of the second fraction, and we are left with y minus 4 and y plus 1. They're not the same, so all of this reduces to y minus 4 over y plus 1. We factored everything, divided out common factors, and came to the final solution. We're going to divide the first fraction, x squared plus 5x plus 6 over x squared plus 8x, by the second fraction, 2x squared plus 5x plus 2 over 2x squared plus x. The only difference between multiplication and division of fractions is that when we divide, we multiply by the reciprocal of the second fraction. Let's look at each numerator and denominator and write them in factored form. Now, factor the numerator of the first fraction. We are going to factor x squared plus 5x plus 6. Next, we are going to write x and x. So we are looking for two numbers with a product of 6 and a sum of 5. The product of 3 and 2 is 6, and the sum is 5. Now we will factor the denominator of the first fraction. The greatest common factor is x, so we will write it as x times x plus 8. Then, the division symbol becomes a multiplication symbol, the denominator of the second fraction becomes the numerator, and the numerator becomes the denominator. We put an arrow to remind us to switch the places of the numerator and the denominator. Now, we're going to factor the denominator of the second fraction and write it in the numerator. The greatest common factor is x, so we have x times 2x plus 1. We are going to factor the numerator of the second fraction, which now becomes the denominator. Now, the leading coefficient is not 1, but 2. We are going to use the trial and error method. We have 2x and x. Now we're going to find two numbers that have a product of 2. Those numbers are 2 and 1. If we put the 2 in the second set of parentheses and the 1 in the first set, that will create 2 times 2 plus 1 to get us the 5 that we wanted. We're going to reduce the common factors. There is a 2x plus 1 in the numerator of the second fraction, and also in the denominator of the second fraction. Those divide out. There is an x plus 2 in the numerator of the first fraction, and also in the denominator of the second fraction. Those divide out. Now we have an x in the denominator of the first fraction, and in the numerator of the second fraction. Those also divide out. So, we are left with x plus 3 over x plus 8. We're going to divide x plus 3 over x minus 3 by 9 minus x squared all over 1. The key to dividing rational expressions is to rewrite each numerator and denominator in factored form. The first fraction is already in factored form, so we'll rewrite it as x plus 3 over x minus 3. Remember that dividing fractions is the same as multiplying by the reciprocal of the second fraction. So that means that the second fraction is going to flip over. The numerator becomes the denominator, and the denominator becomes the numerator. Now, 1 becomes the numerator. Before we write it as the new denominator, we are going to factor the numerator. We have 9 minus x squared. We have two perfect squares and a minus sign, so we have the difference of two perfect squares. That factors into 3 plus x and 3 minus x. Now we are going to divide out the common factors. We have x plus 3 in the numerator of the first fraction, and we have 3 plus x in the denominator of the second fraction. Remember that addition is commutative, so x plus 3 is the same as 3 plus x. Now we can divide out those common factors. We have 1 in the numerator, and we have x minus 3 times 3 minus x in the denominator. There is nothing else to divide, so this problem is done.